For problem 5, we wish to confirm if the output voltage V0 is equal to 120 volts at time equals to 0.25 seconds. We also want to check whether the diodes have been correctly replaced with the corresponding off and on state by verifying the corresponding off or on diode conditions. The givens are VAB is equal to 120 volts, VBC is equal to negative 60 volts, and VCA is equal to negative 60 volts. And R is equal to 10 ohms. And all the diodes are to be assumed as ideal diodes. Dealing with balance through phase rectifier. This basically means that all the voltages have the same magnitude and their phases are a third or 120 degrees off. Also, we're using a three-phase to convert three-phase AC to DC. And since we are assuming ideal diodes, we are looking at the ideal diodes as either being in an on or off condition. And the diodes that are in an on condition, they behave like a short, and the diodes that are in an off condition, they behave like an open. So our first step is to check which diodes are in the on or off condition. As you can see, diode 1 and diode 5 are in the on condition. Diodes 2, 3, 4, and 6 are in the off condition. Now that we determine which ones are in the on and off conditions, we have to write down their statements, which are, in the on condition, VD has to be equal to 0 volts, because in the on condition, the diode acts like a short circuit, which means the voltage going through it is equal to 0. But in order to prove that's in the on condition, we have to prove that the current going through the diode is greater than 0 amps. And for the off conditions, it acts like an open circuit, which means that the current going through it is 0, but we have to prove that the voltage is less than 0 volts in each of the off conditions. So in order to prove that diodes 2, 3, 6, and 4 are in the off conditions, we're going to use KVL. So starting off with diode 2, we're going to start from here, going through the 120 volts, and coming back. And that gives us VD2 plus 120 volts equals 0, which gives us VD2 equals to negative 120 volts. And for diode 3, we're going to start from here, right around, go through the negative 60 volts, and that gets us VD3 equals to negative 60 volts. And so we would do the same thing for diodes 4 and 6, and for diode 4 we would get negative 120 volts, and diode 6 we would get negative 60 volts. And so if we go over here, so we gotta remember that since these are in the off conditions, each diode will act like an open circuit, which means that the current going through it is going to be equal to 0 amps. But we had to prove that the voltage had to be less than 0 volts. And as you can see, for diode 2, we saw that it was a negative 120 volts, which is less than 0 volts. So that makes diode 2 being good for the off condition. And thus forth for diode 3, diode 4, and diode 6. You can see that they are all on the off condition. So before verifying the conditions for the on ideal diodes, we first have to solve for the current going through this resistor. And in order to do that, we are going to use Ohm's law. And as you can see, the current is going to the positive, which means that in our equation, V0 is going to equal positive IR. And from that, that'll give us IO is going to be 12 amps. And now from there, we can use that to solve for the current for ID1 and ID5. And we're going to use this node right here to solve for the current for ID1. And as you can see, ID1 is entering this node and IO is leaving this node, which gives us ID1 minus IDO. And since IDO is equal to 12 amps, that'll give us ID1 is equal to 12 amps. And for this node right here, we're going to use ID5 entering it and ID1 leaving a node. And that will give us ID5 minus ID1 equal to 0, which will give us ID5 is equal to 12 amps. Thus, we have proven the conditions for the on ideal diodes, where diode 1, 12 amps is greater than 0 amps, and B is equal to 0 volts because it acts like a short and there's no voltage going across it. And for diode 5, 12 amps is greater than 0 amps and V is equal to 0 volts. Thus, we have proven that the on ideal diodes are in actually the on case. Now that we have proven that the diodes are in their respective on and off conditions, now we must prove that the voltage for V naught is 120 volts at t equals 0.25 seconds. And we will do so by using KVL. So we will do VAV plus V naught equals to 0. And it is negative 120 volts plus V naught is equal to 0. And thus, V naught is equal to 120 volts. So yes, at time equals to 0.25 seconds, the voltage for V naught is 120 volts. Also, as you can see on the graph right here, you can see at time equals to 0.25 seconds, it is 120 volts.